Hello and welcome to the 28th episode of the Python tutorial series. Today we are going to look at exceptions and how to handle them. But first, let's write a piece of example code. We can say def calc square root of n, and then we can say result equals sqrt of n, and finally return result. If we run our code and say calc square root of 4, we can see that our function works correctly. But if we say calc square root of -4, we can see that we get a value error. This is where expert programmers are able to catch such errors before they occur and deal with them accordingly. So make sure to subscribe to the channel so you can learn all about these tips and tricks and become a Python expert. Returning to our example, let's look at a diagram to better understand how to handle errors in Python. Let's imagine you have a piece of code that works, but can sometimes generate errors. Well, the best syntax to use in this case is the so-called try and except syntax. We can try our code, and if it generates any errors, we can run an alternative code which will normally give either some feedback to the user or perform some additional tasks to correct the error. Remember that we can also specify the type of error we want to handle. Here are some examples. We have a value error, which applies, for example, if we try to calculate the square root of a negative number. An index error, which occurs if we reference an index which is not contained in a list. A key error, which relates to dictionaries. An import error, which concerns libraries. And a memory error, which means that we have run out of memory on our computer. These different error categories means that you can target specific errors and also provide different alternative codes for each different error. Let's look at an example. We can write a function which we can call calc square root as before, and we can give it two inputs, an array and an index. We can then say result equals sqrt of the index element of our array, and finally we can say return result. If we run our code, we can then write calc square root of, let's say, 1, 2, 3, 4 and -4. Let's include a negative number in there. And let's say we want to take the second element, which has an index of 1. As you can see, this returns the square root of 2 as expected. Now let's try calc square root of 1, 2, 3, 4 minus 4, 4. In this case, we try to calculate the square root of -4, which in the real number domain at least cannot be done, so we get a value error. For our third attempt, let's write again calc square root of 1, 2, 3, 4 minus 4, but take the 11th element. In this case, we are referring to an index that is outside the length of the list, so we get an index error. Now let's go back to our code and modify it to cope with the errors we have just seen. First, let's write try, and we can insert our original function into the try command. Then we can say except, and we can say value error, and we can say result equals please try a different number. Again, we can say except, index error. And this time we can say result equals please select a different index. And finally, as before, we can leave our return result. Now let's run our code and try the same examples we had before. So we can say calc square root of 1234 minus 4 and say 1, and as before we get the square root of 2. Then we can say calc square root of 1234 minus 4 of the fifth element, which will have an index of 4, and as you can see it gives us the correct output. Finally, we can say calc square root of 1234 minus 4 index 10, and as you can see it catches our error index. The code still works correctly when an appropriate number is given, but as soon as it incurs in either of the errors we saw earlier, our two except statements will catch the errors and run their respective alternative codes, which in this case print two feedback messages to the user. As you can see in our example, we've specified the alternative code for only two types of errors, because these are the ones we expect will be the most common. But alternatively, we can also provide a general except statement where we don't specify the type of error it pertains to, and this will have a single alternative code. This will catch pretty much all errors, but offers a lower level of flexibility in your code, as the alternative code you write has to provide a blanket solution to all errors, and this may sometimes be quite tricky to accomplish. Having said that, we have now reached the end of this episode on how to handle exceptions. Do you have any other topics you would like to see or any questions about coding in Python? Then make sure to leave a comment down below. If you enjoyed this video, make sure to like, share it with your friends, and subscribe to the channel. If you now feel like putting your coding skills to the test, then take on my coding challenges. You can find a link to these in the top right-hand corner of your screen, as well as in the video description. If you've missed any of my previous tutorials, then check those out by clicking on the box in the top right-hand corner of your screen or on the links in the video description. I look forward to seeing you next week, and as always, happy coding!